Okay, here we have a question that begins with a table of probabilities. Now, sometimes the probability question might look like the binomial question or vice versa. Here, this is very clearly not binomial, so you know the other question that looks vaguely probability related on the paper is probably going to be the binomial. Probability questions come in all shapes and sizes, and they're the ones to look at the biggest variety of you can when you're preparing for the exam. We've got to understand the table, so we've got 3 people and we've got their journeys to work and the probabilities of those, and we've got to calculate the probability that on any given school day morning all of them walk to school. Well, there's only one way that can happen. Rita's got to walk, Saeed's got to walk, Ting's got to walk, so we're dealing with these probabilities. We want all of those 3 things to happen, so you combine those probabilities in a particular way. For the second one, we want only Rita travels by bus to school. So Rita's going to be travelling by bus, and the other 2 are going to be not travelling by bus, but we don't care which of the others. So it's actually this column we're using, but these 2 numbers, because we want them to not travel by bus, we have to look at the probability of the event not happening, and for that you have to do a subtraction from 1. But there is only one way that can happen. Rita goes by bus, Saeed doesn't, Ting doesn't, so there's once again a simple set of 3 probabilities to combine in a particular way. However, in part 3 we've got at least 2 of the 3 students cycling to school, and there are several ways that could happen. For example, Rita could cycle, Saeed could cycle, and Ting could not cycle. Or Rita and Ting could cycle and Saeed not. And there's also the case where all 3 of them cycle. There are actually 4 different cases altogether, so you work out 4 separate probabilities listing all the different ways that could happen, and then because they're separate cases, they're exclusive possibilities, you can actually add those probabilities up at the end. So that's the third part of A. On to part B. So in part B we've got Ursula, who's a friend of Rita, who never travels to school by bus. So there are only walking and cycling possibilities for this new person. We've got to calculate the probability on any given school day morning that Rita and Ursula travel to school by the same method. So it's got to be either walking or cycling, and again you do it in cases. So the first case will be Rita cycles, and we've got all the probabilities for what Rita might do here. It's the same method, so Rita cycles and then Ursula cycles. So you look at the probability of Rita cycling and then the probability of Ursula cycling given that Rita's cycling. And that's one case. And then you look at the other way, they could both travel by the same method, and you add those 2 cases together for 3 marks. But then B.E2 is the probability they use different methods. Now you could list lots of cases for the way they use different methods, and there'll be lots of different possibilities, but there's a link between these 2. If you've just got the probability they use the same method, then the probability they use different methods is the probability of this not happening, and you should remember how to get the probability of an event not happening very simply, which is why it's only worth the 1 mark.